All right, good morning, everybody. So today we are going to continue discussing our point slope form, which is chapter 4, section 3. And I'm going to show you some examples today that I kind of alluded to a little bit yesterday when I said that you have to be careful in the problems that sometimes they will ask you in the problem to put your final answer in a different form than what you use to actually write the equation. So what I mean by that is this: in all of these problems that we did yesterday, they said write an equation in point slope form. So we used point slope form to come up with an equation of a line, and we were able to leave that equation in point slope form. We didn't have to do anything else to it. What we're going to do today is we are going to use point slope form, and then we're going to put it into a different form. Now, again, let's scroll up here for a second. Remember, we have three different forms of a line. We have slope-intercept form, which is probably the most familiar to you, which is the y equals mx plus b. You can see that we solve for y. We get y by itself. But there's also standard form, where you can see the x and the y are together on one side, and then the constant is on the other side. That is another form of a line. And then now the third one that we just learned yesterday is point slope form. So what you have to understand is you can have the same equation, the same line, but it can be represented in three different ways depending on which form of the equation that you're using. And so that's what we're going to show you kind of today. And so it says write the equation of a line in slope-intercept form that passes through, and then it gives you this right here. And so what they actually did is they already gave you the equation of the line. It is in point slope form. So what we need to do is to remember that slope-intercept form is y equals mx plus b. And to get it into slope-intercept form, we've got to get the y completely by itself, right? There cannot be anything else with the y. Now, if you look right here, there's just a -4 with the y. So that's going to be easy enough to get rid of. The other thing that you do need to notice, though, is that there's a set of parentheses over here. We cannot leave a set of parentheses in here because if you look at slope-intercept form, there's no parentheses in there. So there's two things that we need to clean up in this equation. We need to clean up the set of parentheses, and then we need to get rid of that -4. Now, we are going to actually clean up the parentheses first. And the way that we're going to clean up the parentheses is we're going to distribute that -1 to both things. So when I do that, I end up with y minus 4, still the same on the left, but then I get -x minus 2. And so now you can see we don't have any more parentheses, which is a good thing because we're trying to get it into slope-intercept form. And slope-intercept form doesn't have any parentheses. The last thing that we need to do for slope-intercept form is to get the y by itself. In order to get the y by itself, we need to get rid of this 4 right there. And so to get rid of that 4, we're going to add 4 to both sides. Now, if you notice, I am lining up the +4 with the like term, -2. Okay, so then these will cancel, and I'm left with y equals -x plus 2. There is your final answer. And you can see mx plus b, how nicely it lines up with slope-intercept form. You can get your slope, you can get your y-intercept. So what I did here is I changed it from, this right here, whoops, I don't want to use that. This right here is point slope form. This right here is slope intercept form. Now, they represent the same line. If you graph these two equations, they would be exactly the same line on a coordinate plane. They are just written in two different forms. So moving on to F, this is the same type of problem. They give us an equation that is in point slope form, and they want us to put it into slope intercept form. And the first thing we're going to do is we're going to distribute the 6. And then the last thing that we need to do is to get the y by itself by subtracting 5 from both sides. And when I do that, I get y equals 6x minus 29. Okay, so what you saw up here, that's point slope form. This form right here is slope intercept form. And you can see y equals mx plus b. It lines up perfectly with that. Now, this is the same type of problem that we've done the last two times. Now, this one is a little bit different in that our slope now in point slope form is a fraction. We have negative 1/2. So we do need to deal with that negative 1/2. Once again, we're trying to put it into slope intercept form, which involves solving for y. It also involves getting rid of any parentheses that you see there. And the way that we get rid of those parentheses is we distribute the negative 1/2. So I'm going to have y plus 8 equals, and we're going to have negative 1/2 x, and then negative 1/2 times 4. So you need to take half of 4 and then make it negative. So half of 4 is 2, and we're going to make it negative. So it becomes negative 2. Okay. Now from there, we're going to subtract 8 from both sides. And you can see I have y equals negative 1/2 x minus 10. And so this right here is point slope form. This right here is slope intercept form. Same line, just expressed in two different ways. Okay, so we have a few more. So this is write the equation in standard form. Okay, so the last couple of problems that we did, we had to write our final answer in slope intercept form. This time, we're going to take it from point slope form and we're going to put it into standard form. Now, standard form is ax plus by. So that means the x and the y are on the same side, and then the number, the by itself number, is on the other side by itself. So let's get started. Same concept. We're going to distribute the negative 1 to get rid of the parentheses first. So you can see negative 1 times x is negative x, and then negative 1 times negative 9 is positive 9. Okay. Now, this is where it's different than slope intercept form. If it was slope intercept form, we would want to just move this 3 over and then we would be good. But this isn't slope intercept form. This is standard form. So we got to get the x and the y together on one side. And right now, if you look at our equation, the x is over here and the y is over there. So that is not standard form yet. So what we need to do is add x to both sides first. Now notice I'm not lining up the x with anything else because there are no like terms on the left-hand side. So it's simply going to be x plus y minus 3 equals 9. Okay, so we're almost there. You can see we have the x and the y on one side, but the c stands for constant. And what that means is those are the numbers that are by themselves with no letters or variables. And we still have this pesky 3 right here, this negative 3. So we need to get rid of that by adding 3 to both sides. And when we do that, we get x plus y equals 12. And if you look, that lines up perfectly with standard form. You can see a is 1 because there is no number there, it's 1. B is also 1 because it's 1x and 1y. And then c is 12. So again, this is point slope form. This right here is standard form. And once again, these are all the same lines. If you were to graph them, they're just being expressed in a couple different ways, either point slope or standard. Okay, so here again, we're given an equation in point slope form, and they want us to put it into standard form. So it's the same as all the other ones. We're going to distribute the 2 first. Once we've distributed the 2, we then have to get the x and the y together. So we need to move this 2x over. So we're going to subtract 2x from both sides. So I have negative 2x plus y plus 6 equals negative 14. Okay, so I move the 2x over with the y and the 6. But again, x and y are together. The constant has to be over on the other side. So that means we need to get rid of this 6 by subtracting 6 on both sides. And when I do, I get negative 2x plus y equals negative 20. Now, there's something that I have to tell you about standard form. And that something is this first number that's on the x is not allowed to be negative if it's proper standard form. So what that means is I'm going to have to go through and divide all of these by negative 1. When I do that, I get 2x minus y equals 20. And now all that did is it made this beginning term, this x term, to be positive. I don't know why that is. That is just what the rules are for standard form. So the standard form, the lead coefficient, the one that's on x, needs to be a positive number. So if it's not, you need to divide the entire equation by negative 1 to make it positive. So this right here is standard form. Okay, remember what we started with. We started with point slope form. Okay, so I have one more to show you. And this one's a little bit more complicated because of, you can see there's a negative 2/3 right here. So once again, we're starting with something in point slope form. And it says write an equation of the line in standard form. So we need to take this and put it into standard form. The first step to that is distributing this negative 2/3 to both sides. Now, I'm going to do the scratch work off to the side. We have negative 2/3 times negative 15. Now, in order to do that, we're going to make it negative 15 over 1, and then we're going to multiply straight across. But don't forget, before you multiply straight across with fractions, you should always look on the diagonal and see if anything will reduce. And in this case, 3 and negative 15 are both divisible by 3. And so when we do that, we get a negative 5 up at the top, and then the 3 turns into a 1. So now when I multiply straight across, I have negative 2 times negative 5, which gives me 10, and 1 times 1 is 1. So 10 over 1 is just 10. So when I distribute over on the left-hand side now, when I distribute this negative 2/3 to the negative 15, I end up with positive 10. Okay, now there's a couple more things we need to do. First, we need to move the x term over. So I'm going to add 2/3 x to both sides. And by doing that, I end up getting 2/3 x plus y minus 1 equals 10. I need to get rid of that 1 that's on the left-hand side by adding 1 to both sides. Okay, so when I do that, I get 2/3 x plus y equals 11. Now, here's the other thing that you need to remember about proper standard form. Not only can the lead coefficient not be negative up like we had in this problem here, where I had to divide all the stuff by negative 1, okay, because this 2 was negative. It's not allowed to be negative. It has to be a positive number. In proper standard form, you are also not allowed to have fractions in the equation. So we need to get rid of that 2/3. And in order to get rid of that 2/3, we have to multiply the entire equation by the denominator. In this case, it's a 3. So this 3 is going to multiply the 2/3, it's going to multiply the y, and it's going to multiply the 11 to give us an equation. So the 3's on the first one cancel, and we're just left with 2x. And then 3 times y is just 3y. And then 3 times 11 is 33. And so you can see when I multiplied through by 3, it eliminated that fraction. So now what I have is proper standard form. So proper standard form cannot have the lead coefficient be negative, and it also cannot have any fractions for the numbers that are on X and Y. And that's how you get rid of that. So there you go, guys. That's what I got for you today. As always, if you have any questions, feel free to email me or speak up during our live Google Meets. Have a great day.